Hello everyone. Thanks for taking the time to join our What's New in Alibre 2018 webinar for this month of May. My name is Joe Anand and I'm, among other things, the product manager for AlibreCAM. I'll be joined today by Uday Honalagare, who is our support manager, who will be doing the demonstration of the product to showcase all the new features that we have in AlibreCAM. As you may or may not know, we released AlibreCAM 2018 earlier this month, so we got some exciting new changes. We had worked with the Alibre development team. Shout out to them who had given us some really nice API fixes that we had wanted, that it would allow us to actually add significant new functionality to AlibreCAM 2018. And we will be talking about that in a minute. But before we do that, a few housekeeping tips. The recording of this webinar will be made available, and we'll be sending it out. The link, it'll be a YouTube link that we'll be sending it out to all the registrants, maybe in a day or two, once we clean it up. The format is we are going to have a demonstration followed by 10 minutes of questions at the end. But we also want to keep it very interactive. So if you have any questions, just go ahead and use your chat window and type your questions in, and we can, if there's something we need to demonstrate, we can always ask Uday to do it, or if we don't have the time, we can always send information back to you by email, and we'll also be monitoring the chat window, so we'll be answering your questions as well. So what we're going to be showing today is basically all the new features that we've introduced in 2018 AlibreCAM product. The first topic would be the mill module enhancements. Mostly we are focused on the mill module for the 2018 product. We have whole host of enhancements in 2, 3, 4 axis, as well as whole machining. And then Uday is going to be showing some of the general productivity and the user interface enhancements that have gone in. And then finally, the most important part of the presentation is introducing the simultaneous 5-axis toolpath methods. We were not able to do that in the previous versions. As I had mentioned, the API change that the Alibre folks had given us has enabled us to introduce these exciting new module, the continuous 5-axis toolpath methods. And then some of the other enhancements for clearance geometry, feeds and speeds, and then simulation, which will include machine tool simulation as well. And finally, knowledge base enhancements for productivity improvements. So without any further ado, let me let Uday take over and do the demonstration. Uday?
Thank you, Joe. Hello, everyone, and thank you for joining us for today's What's New webinar in AlibreCAM 2018. And as Joe pointed out, we will be covering all of the new features. I'm really excited to go over all these new features in AlibreCAM 2018 with you. And please feel free to post your questions in the questions panel as we go through the webinar. Now, AlibreCAM 2018 is certified to run in Alibre Design 2018. So if you're running an older version of Alibre, you need to update to the latest version to be able to run AlibreCAM 2018. So we're going to be covering first, starting with our enhancements to 2-axis or 2.5-axis toolpath methods. I hope everyone is able to view my screen. So if you have difficulty hearing my voice or seeing my screen, please go ahead and raise your hand in the GoToMeeting panel, and we'll try to make sure everybody is able to, hear us and see my screen.
Today we're getting a little bit of an echo from your microphone, so if you want to adjust that, that might be better.
Okay. Hope this is better.
Go ahead. Yeah.
Thank you. Okay, so I have a prismatic part that's modeled in Alibre. I've loaded into the workspace in here. So I'm going to go over to the Add-ons tab, locate the AlibreCAM 2018 menu, and then click on Mill, and this automatically loads the mill interface in AlibreCAM. So we have the machining browser over on the top half and the machining objects browser, as you're familiar with, on the lower half of the screen. So the first new enhancement I'm going to talk about in 2-axis is going to be 2-axis fillet machining. This is a brand new method that's been introduced in AlibreCAM 2018, and it's available starting with the standard configuration. So if you have standard, expert, pro, or premium, you will have access to fillet machining in AlibreCAM 2018. So this is a very nice toolpath method that will allow you to program fillets if you have the fillets modeled in your solid geometry, or if you just want to program a fillet toolpath around the edge of the part. So you could define your tool for fillet machining. It could be typically a ball mill, or it could be one of those fillet mill tools if you have the radius that matches the radius of the fillet. So you could define it and then program a fillet machining operation in here. So I'm going to go over to the Simulate tab and give you a quick run through of that here. So I'm going to simulate through all the other operations and then run a simulation of the filleting operation in here. So you'll notice that the fillets are being applied towards the exterior edge of the part. So there's your fillet machining operation, which is a brand new method that's been introduced in AlibreCAM 2018, and it's available right from the standard configuration of AlibreCAM. Now the next enhancement I'm going to talk about is the enhancement that we have introduced into chamfer operations. Again, you can find the chamfer operations under the two-axis methods. In the chamfer operations, you could now also specify the chamfer height in addition to the width. So in the previous versions, you were able to set the width for the chamfer. Now in 2018, you can either set the width or you can specify the height for the chamfer. So depending on what parameter would work best for you, you could pick one or the other and program chamfer operations in AlibreCAM 2018. So I have a chamfer toolpath programmed in here. And as you can tell in the cut parameters, I've set the chamfer width to 1/16 of an inch. So depending on the tool that you specify for the chamfer, if it's a 45 or a 30-degree chamfer tool, the height and the width would be automatically computed based on the parameters that you put in here. So this is also a new enhancement that's been introduced in 2018, and it's available starting with AlibreCAM standard configuration. The next enhancement I'm going to go over is the enhancements that we've made to the drilling operations in AlibreCAM. So I'm going to go ahead and pull in an example for that. So again, we'll switch over to AlibreCAM, load the CAM browser, and you'll notice under hole machining and tapping, we've now introduced the option for peg tapping. Peg tapping is similar to how you can do a peg drilling operation. So you can specify your tap depth, and then you have the parameters where you can specify your peg increment or the step increment for the tapping operations that can be set. Now, depending on the type of controller that you're working with, you could be outputting the peg tapping with just a Q value, which represents your peg increment. Or if you have a Haas type of a controller, you may want to break it down into multiple different lines of code. So we can support both types of output. We could use the standard FANUC type of output, or for Haas machine tools where you need the tap increments to be output in separate lines. So we support both these formats, and you can find out more about this in our online help on how to configure the post to output in the desired format for your machine controller. Now these are, again, the peg tapping method is available starting with the standard configuration of AlibreCAM. So standard and all the higher configurations will include peg tapping operations. The next thing I'm going to cover is enhancements that we've added to the two-axis methods, where we've improved the high-speed pocketing cut patterns and pocketing operations. So the high-speed cut pattern has been made more robust. There's been numerous improvements and fixes to the high-speed pocketing operation. And this is one of the examples where you can see the high-speed pocketing toolpath operation, which is offered in two-axis pocketing and also available in three-axis roughing method. So there's been enhancements and fixes done to the high-speed pocketing cut pattern as well. Now the next thing I'm going to cover is enhancements that we have added to our three-axis machining methods in AlibreCAM. First, I'm going to start out with an enhancement that we have introduced to our three-axis horizontal finishing operation. The three-axis horizontal finishing operation is offered in AlibreCAM standard and higher configurations. If you're running standard, expert, pro, or premium, you will have access to 3-axis horizontal finishing, and you can find it under the 3-axis menu in horizontal finishing. Now first I'm going to talk about what we did in the previous versions of AlibreCAM for horizontal finishing. So in the previous versions, we used to retract to the clearance plane when a containment region was selected, and as you can see here, the tool is retracting to the clearance plane. Now in 2018, there's an additional option which is called follow containment. So the toolpath will follow the containment region, and this option can be found under your cut parameters tab for tool action when containment is encountered. So you can choose follow containment, and this is by default the selected option when you program a horizontal finishing operation in 2018 AlibreCAM. So this is a nice enhancement, eliminates the additional retract and transfer motions and makes a continuous cut motion as it follows the containment area. We've also made improvements to other 3-axis methods, and one of the methods I'm going to go over here is the 3-axis parallel finishing operation. Now in 3-axis parallel finishing, we've introduced an option to be able to sort the sequence. The cut ordering can be sorted in 3-axis parallel finishing. Now in previous versions, it used to basically sort in the order in which you selected those regions in here. So in this particular example, you can see that the toolpath transfers from one region to the other based on the order in which you had them selected and programmed. And I'm going to go over a quick animation of the toolpath in here. As you can see, it jumps from one to the other. So now with the 2018 version, we've added the ability to be able to sort the sequence of order in which you're going to be cutting, and this can be specified under the sorting tab. So there's a brand new tab called sorting, which is available in 3-axis parallel finishing, and you can choose the sorting type to be either a minimum distance or directional sort. So this interface looks very similar to our sorting techniques that are offered in other operations where you've noticed in drilling or 2-axis operations like profiling and pocketing. So now we've also introduced the sorting option in 3-axis parallel finishing. And again, the 3-axis parallel finishing is available. The sorting is available in a configuration starting with our standard configuration. So you'll notice that it's sorted from a minimum distance based on 2 or more regions that you selected. Now the same sorting feature is also available in one of the advanced 3-axis methods, which is 3-axis projection pocketing. And 3-axis projection pocketing is included starting with our Pro configuration of AlibreCAM. So if you go over to the sorting tab, you'll notice that this option has been added to 3-axis projection pocketing as well. And you can specify a sorting sequence on the 3-axis projection pocketing as well. So the toolpaths are now sorted based on minimum distance between containment regions. So this is a very nice option which makes your programming a lot more efficient and minimizes the transfer motions and makes it more efficient and reduces your machining time. Now folks, if you do have any questions, please feel free to post those questions in the questions panel, and we'll try to get those questions answered for you. The next enhancement I'm going to cover is the enhancement that we've introduced to 4-axis machining in AlibreCAM. The first thing I'm going to cover is a brand new method that we've introduced in 4-axis machining. Now the 4-axis methods are included starting with expert configuration of AlibreCAM. So if you have expert, professional, or premium, you will have access to 4-axis methods, and the 4-axis methods can be found under the program tab under the 4-axis menu. So we've introduced a new method called create round. Now this method is typically used in applications where, let's say you have a woodworking application and you're starting out with a rectangular piece of stock material, and typically you would want to turn the corners into round, and we've added a new method called create round under 4-axis. So in this method, it automatically takes into account your stock geometry in the part and creates, removes the material on those edges to turn it into a round stock from a rectangular stock. So very useful method in applications like woodworking, and could be also used with other applications. So the create round operation, here's the toolpath preview for the create round operation as you see it. And I'm going to go to the simulate tab and run a verification for it. So as you can see, I'm using a linear cut pattern in here. And it's basically going through all those 4 corners to turn it into a round stock. So this is one of the brand new methods that's been introduced in AlibreCAM 2018. And again, this is available starting with expert configuration of AlibreCAM. Now we've also introduced a new cut pattern in 4-axis parallel finishing operation, and this is called the helical cut pattern, and you can find this under the cut parameters tab in parallel finishing by selecting, in addition to across cuts and along cuts, you now have the option to select helical cut pattern. So this would create a continuous helical toolpath, eliminating the step over marks or tool marks that you used to notice when using across cut patterns or along cut patterns, and resulting in a nice continuous toolpath in here. So I'm previewing the toolpath on top of this model in here. Let me just run a quick animation so you can see the toolpath motion. So this is basically a helical cut pattern, a very nice way to program a wide range of parts. And I've applied the same helical cut pattern with a much tighter step over on this example in here. And this is also available in starting with the expert configuration of AlibreCAM. The helical cut pattern in 4-axis. So these are a couple of very nice enhancements that you can see in the 4-axis methods, which can be used for a wide range of part types that you're trying to program. The next thing I'm going to cover is a brand new class of method which is called surface-based machining for 4-axis, where you would be able to generate true 4-axis methods or toolpath methods in AlibreCAM. So this is called drive surface machining in AlibreCAM, and with the help of the new API in Alibre Design 2018, we were able to introduce this method called 4-axis drive surface machining. And this method can be found under the 4-axis methods. It's called drive surface machining, and again this method is available starting with the expert configuration of AlibreCAM. So if you're running expert or professional configuration, you will have access to this brand new method called drive surface machining. And with this method, you'll be able to pick the surfaces that you'd like to machine, and it can handle a new set of class of parts. In this example, what you're looking at is the part is dipping below the rotation center in here, and you'll be able to program parts like these using a true 4-axis method where you have the 3 linear axes and the rotational axis. So all 4 axes can move simultaneously in here. So you can select your drive surfaces in the drive surface machining method. So you can highlight the surfaces, select them, and you can also orient the normals, or if you need to reverse the surface normals, you can flip the normals in here and specify your cutting parameters, whether you want to cut across or along axis, and your step over controls. Very similar to the other parallel finishing operation, how you have the controls in here. So this is a true 4-axis method. We call it the drive surface machining, and the tool remains normal to the surface that's being machined. And let's run a quick animation, and then we'll run a simulation as well to take a look at it. So you'll notice that the tool is remaining normal to the surface being machined at all times. Now let's
let me interject here and explain what true 4-axis means. So when we say true 4-axis, what we're talking about is actually the tool is moving, the tool or the table they're all being moved in four complete different axes. So you'll have the X, Y, Z motions for the tool, as well as an angular rotation of the table or the head. So that's what we're talking about when we say true four-axis. In our other toolpath methods, usually what happens is the Y or the X, depending on your machine tool configuration, is locked. So the tool moves in X and Z in the case of a rotation about the Y-axis, as well as a rotary axis. So in reality, you're getting a three-axis, even though it's a rotary motion. But here in this particular toolpath method, you're getting all four simultaneously moving axes. So hope that explains that a little bit.
So I have a simulation with the machine tool running in here. As you can see, it's moving in X, Y, Z, and also the rotational axis. And on the left, what you're looking at here in the split window is the toolpath animation. Here is with the machine tool. You're looking at the simulation where you can notice, as Joe pointed out, you're seeing the X, Y, Z, and then the A. So it's a true four-axis machining toolpath method. Okay. So I would like to talk about some of the additional enhancements that have been introduced here. Since we are looking at this particular model here, we wanted to mention about the enhancements that we made to simulation in here. So we've actually added additional simulation models. We have added additional machine tools for simulation, and these machine tool simulation comes included starting from the expert configuration of AlibreCAM. So there are several new machine tool models that have been introduced and added in here. So you can go over to the machine tool setup. Under machine tool definition dialog, as you pick load from file, you will see that the machine tool simulation for several additional machine tools have been added and introduced in version 2018 of AlibreCAM. This is just one of many simulation enhancements. I'm going to go over and cover some of the productivity and user interface enhancements in AlibreCAM 2018. The first thing I'm going to talk about here is how you can suppress and unsuppress machining operations in 2018 version of AlibreCAM. So I'm switching back to this example that we had covered a little while earlier in this webinar. So you could select one or more operations that you already programmed, and if you'd like to suppress them, you can select the operations, right mouse button click, and on the right mouse menu, you'll see there's a new option called suppress. Selecting suppress suppresses the operation which basically allows you from previewing the toolpath, and it'll when you generate the setup or operations, the suppressed operations will not be generated, and also they will be excluded from post-processing as well. So this gives you the ability to suppress certain operations that you do not want it to be post-processed or simulated. So suppressing an operation will exclude it from post-processing, simulation, and also displaying the toolpath. You could suppress a setup, you could suppress a machining operation set, or one or multiple operations. And when you suppress it, you will notice that the indicator here shows a little lock on it, so it's suppressed. You could go back and right-click and unsuppress the operation if you need to unsuppress it before post-processing. And this feature is available in all our configurations of AlibreCAM starting in version 2018. It's a very nice productivity and tool available in AlibreCAM, so you don't have to delete the operations or recreate them, so you can suppress them if you don't want those operations to be post-processed. One of the nice enhancements I would also like to talk about is being able to view the toolpath in some of the hidden areas. So meaning when you have a model that's shaded in display, if you wanted to view the toolpath, you don't have to rotate the model view to take a peek at it. You could actually toggle this on by selecting toggle toolpath in hidden areas, and you can see that it displays the toolpath that is in shaded areas or hidden areas, so it's easier for you to view the toolpaths. So for example, if I go ahead and unsuppress this operation in here, I can click on this toggle to view the toolpath, so you can see the toolpath going to the entire depth without having to rotate the model view to view the toolpath. This is also one of the very nice enhancements that's been introduced in AlibreCAM, and it's available to you in all configurations of AlibreCAM. Now, one of the nicer enhancements is being able to save one or more operations to a knowledge base. Now, in previous versions, when you choose Save to Knowledge Base, it saves all the operations that are programmed under your setup, or if you had multiple setups, it saves all of the operations into a knowledge base. Now, in addition to that, in our version 2018, I could select individual operations or a group of operations, right-click on it, and choose Save to Knowledge Base. So only the selected operations are now being saved to a knowledge base. So you can pick and choose if you only want to save a limited set of operations into a knowledge base in AlibreCAM 2018. So this feature, Save to Knowledge Base, is available to you starting with the standard configuration of AlibreCAM. Save to knowledge base. You can select a setup, or you can just select one or more operations, right-click, and then pick Save to knowledge base. Now let's take a look at one of the nicer productivity enhancements that's also been introduced in bridges and tabs in AlibreCAM 2018. So as you go over to the Regions tab, and as you define a predefined region with bridge points, in the previous versions, if you needed to move the bridge point over, you had to activate the bridge point in selection and move a bridge point, and then go back and select the command again to move. So if you had multiple bridge points, you had to repeat this over and over again for each and every bridge point. Now with 2018, we've added an option when you double click on this Edit Bridge Points in Selection, this stays in modal, so you can move multiple bridge points at the same time, so without having to reselect the command. So I have the bridge point in selection set to modal here. Now I can move the bridge points for each and every bridge point that you have on the selected predefined region, and then finally you can right click on it to commit the changes or accept the changes. So this makes it a lot easier when you have parts that have multiple bridge points to move those bridge points around. And this feature, the predefined regions, are available in all versions of AlibreCAM starting with standard. So if you're running standard, expert, pro, or premium, you will have access to bridge points. Now let's talk about the enhancements that we've introduced to the clearance and the feeds and speeds in AlibreCAM. The first thing I'm going to go ahead and cover is the enhancements to the clearance definition in AlibreCAM. So I'm going to go over to this example that we worked on earlier. And one of the nice features with the clearance we've introduced is the ability to ignore wireframe geometries when establishing the clearance height. Now to demonstrate this, I'm going to go into the Viewing tab and display the sketch display in here in Alibre. So you can see that when the part was modeled in here, there are some sketches that extend past the extents of your solid model. So you can see that these sketches are extending past. So when you create your clearance definition, or when you define it, by default it accounts for the consumed and unconsumed sketches. It takes into account the bounding extents or the bounding box of the sketches as well. So in this case you can see that the clearance is being much higher than the actual extents of the part. So we now have introduced a new option in here. It's called Ignore Wireframe Geometries in Bounds Computation. So when you select this, it automatically ignores any of the sketches that are participating in the model for establishing your clearance height. So you can establish the clearance height by ignoring it. So it only takes into account the solid surface geometries that you have modeled in the part for establishing the clearance plane. And this is available to you in all the configurations of AlibreCAM. So this is also a very nice enhancement to the clearance definition. Now let's take a look at the feeds and speeds enhancement. The feeds and speeds enhancement has been introduced both in our mill module as well as the turn modules. As you define your tool and go over to the Feeds and Speeds tab, and when you pick the Load from File option, you will notice that there's the option to set the maximum limits for computation for the maximum spindle speed and the maximum cut feed rate. Now this would depend on the maximum spindle speed of your machine tool. So if your machine tool can handle up to 25,000 RPM and a cut feed rate of let's say 150 inches per minute, I'm just using an example in here, these values will be retained, and when you select a tool and specify the material type to establish feeds and speeds, the maximum spindle speed that you set, so the computed values will not exceed the maximum values that you've set for maximum spindle speed and the cut feed rate. This is also a very nice enhancement, and it's available in all our configurations of AlibreCAM in 2018 version. So when you go back into load from file, you'll notice that these parameters are retained and the computed values will never exceed the maximum limits that you've set for feeds and speeds. Now, earlier in the webinar, I covered one of the simulation enhancements where I talked about newer machine tool models, simulation models being added. I would like to cover one of the very nice simulation enhancements for holder collisions that we've added in AlibreCAM 2018, and I'm going to go over that with this example in here. So as you can tell on this particular part, I have programmed a pocketing operation, a 2.5 axis pocketing, and I'm going to run a verification here, and I want you to take a closer look at a couple of things in here. So when I go ahead and run a simulation, you will notice that if a collision is being detected during simulation, a collision of the tool holder with the material, it will mark the operation, or it will flag the operation as dirty, in addition to marking the collision areas in the simulation. The marking of the collision areas in the simulation, we already had this in our previous versions, but the new feature we've introduced is being able to flag the operations with holder collisions automatically, and you can also go into your toolpath editor or toolpath viewer, and you can actually look at the specific lines of go-to motions where you have the collision. So it's going to mark those motions in your toolpath editor or toolpath viewer, and you'll see those collisions are marked as an indicator that shows the collisions in here. And as you step through the into these motions in here, you can actually see the areas of collision right there. So as you select these motions, it will show the collision. You can see the tool holder colliding with your stock material. So this is a very nice enhancement, and again, this is available right from your standard configuration of AlibreCAM in 2018. So it marks the holder collision areas in the simulation, flags the machining operation as dirty, and also marks those go-to motions, specific go-to motions where you run into these holder collisions. Folks, if you do have any questions, please feel free to post those questions in the questions panel, and we'll do our best to answer them for you. The next topic I'm going to cover here is our brand new 5-axis simultaneous module that we're introducing in AlibreCAM with the help of new API that's provided to us in Alibre Design 2018. We are able to introduce this module in here, and I'm going to go over this with an example to show you how you can effectively program simultaneous 5-axis or true 5-axis toolpaths. And we're introducing this brand new premium configuration for AlibreCAM. And we had this premium configuration in our other desktop products, but this is brand new to AlibreCAM. And you will notice that with the premium configuration, you will have a 5-axis toolpath methods displayed in the program tab, and you'll have access to a wide range of 5-axis methods starting from curve projection, flow curve, between two curve, drive curve, surface normal, and swarf machining. Now these methods will be available in 2018 AlibreCAM, and it's part of the premium configuration. So you have 3 linear and 2 rotational axes in a 5-axis. We support 3 different class of 5-axis machine tools. It could be a head-head configuration where the rotation of the the 2 rotational axes is on the spindle, or it could be a combination of a rotary table and a rotary head, or a table, which could be like a trunnion type of a machine tool. Like some of the Haas machine tools are trunnion type where you have 2 rotational tables. So you could be programming any of these class of machine tools, and you can define those in the machine tool setup. And what I have here is an example of a 5-axis, typical 5-axis example where you could program methods using it like a swarf machining, where you can select your wall surface, you can select the floor curve or a floor surface, and specify your cutting parameters for the 5-axis method in here. So I've generated a 5-axis toolpath. I'm going to run a verification in here like a simulation. You can see that the 5-axis simulation is also included with these 5-axis methods. And that in this case we are using a swarf machining, so the side of the cutter is following the surface in here. We'll go through a couple of other.
Just a clarification here, when we are talking about 5-axis, they already mentioned it, but I just want to emphasize it. In our previous versions of the AlibreCAM product, we were able to do 5-axis index machining. What that means is we're actually able to rotate the part in different orientations, part or the tool in different orientations, and then lock it, and then only move the X, Y, and Z axes to machine like a 3-axis or a 2.5-axis operation. So what we call that either 3+2, you might have heard of that term, 3+2 machining, or index 5-axis. We've always been able to do that in our products, but in this release of the 2018 product, because of the API enhancements that we received, we are able to do simultaneous 5-axis motions. So that's a big distinction that I hope we're making clear here. Thanks, Uday.
Thank you, Joe. So this is an example or a good case of a 5-axis swarf machining. We'll take a look at a couple of other examples of 5-axis applications in here. So I'm going to go over to like a handrail in here, which could be used in a woodworking application or one of the other applications. So I'm going to go over to the AlibreCAM mill module, and then in the 5-axis methods, we could program a between 2 curve machining. So you can actually select your 2 rail curves, and then you can select the drive surfaces, the surfaces you'd like to machine. So in the true 5-axis methods, you actually pick the faces of the surfaces that you'd like to program, and then establish the normals, direction of the orientation for the normals, and then generate a toolpath. Now you can see that the interface for our 5-axis method, like selection of your geometry, the tool feeds and speeds, your clearance definition, is very similar to our 3 and 4-axis method. So you can see that how simple it is, the interface, and how easy it is for a user to quickly adapt and learn programming 5-axis. So the interface is very similar to our other modules like for expert or pro configuration. So the ease of use makes it a lot easier to program 5-axis toolpath methods in AlibreCAM. So I have a 5-axis between 2 curve machining method programmed in here. So I have selected these surfaces, and as I select these surfaces, you can see the normals are being displayed on the surfaces. I've picked 2 of these edge curves. I can select the face edges as my drive curves. In the cutting parameters, I can specify the number of axes. I could program as a 5-axis, a true 5-axis, and the toolpath has been generated in here. So I'm going to run a quick animation in here. So I'm going to pick simulate, and you can see that the tool in this particular case stays normal to the surface being machined. So that the tool is it's basically following along the 2 curves, and the tool remains normal to the surface being machined. So this would produce a true 5-axis output. So you have your 3 linear axes and then the 2 rotational axes. So which could be A and B or B and C, depending on how your machine is configured. Now with the introduction of our 5-axis simultaneous module, we also have added a new option where you can lock one of the axes to a 4-axis. Now this would be applicable in the case where the machine tool what you have is only capable of 4-axis, and by using some of the methods in the 5-axis modules, you could lock the axis to a 4-axis, so one of the axes remains locked, and you can program as a 4-axis if the machine tool you have is only capable of 4 axes, and you can still take advantage of these 5-axis methods and lock it to one of the axes. So it basically locks it to one of the planes that are, and then you could program it as a true 4-axis method in here. Now this could be a good example of a true 4-axis method. As you can see here now, the difference between the toolpath animation, if you notice from the previous one to this one here, the tool is being locked to one of the axes, and it's resulting in a true 4-axis method. So this gives you an additional class of machining methods when programming, programming for your 4-axis machine tool by locking one of the axes, and you can take advantage of this in the premium configuration of AlibreCAM 2018. Now this is available in all of these methods type. You can lock the axis to 4-axis, and this is something we introduced as a brand new in version 2018. So you can choose a type of output to be 5-axis or 4-axis. Now I would like to show how easy it is to program a simultaneous 5-axis toolpath on this particular part in here. So I would like to go ahead and machine this wall surface in here, this vertical wall. So I'm going to go ahead and add a method called swarf machining, and I'm going to select the wall surface, the surface to be machined. I'm just going to go pick these 2 surfaces. Holding the shift key allows you to select multiple surfaces in here. And now I'm going to go ahead and select my drive curves. So I'm going to just pick these 2 curves in here, pick these 2 face edges. And in 5-axis, the surfaces that you select as the surfaces are going to be machined, so you may want to gouge check against adjacent surfaces, so you can go ahead and add surfaces to check for gouges against. I'm going to pick these 2 in here. And then you're ready to define your tool in here for the machining operation. You can pick your cutting parameters and then set your clearance definition. So whether you want to use a planar clearance, a spherical clearance, or a cylinder clearance, and you can define the axis about the cylinder which you're defining, and then generate creates your toolpath. So we just programmed a swarf machining toolpath by picking a handful of surfaces in here in 5-axis, and I'm going to go ahead and run a verification for it. So as you can see, it's using the side of the cutter to clean up the wall. So it's very intuitive and easy to work with the introduction of the simultaneous 5-axis module in our premium configuration. So I've demonstrated all of the new functionalities, enhancements that we've introduced in our version 2018 of AlibreCAM. Folks, if you do have any questions, please feel free to post those questions in the questions panel, and we'll be glad to assist.
Uday, there's a question here. Do you have high-speed adaptive machining? Yes, we do. We call that high-speed machining. I don't know if you have something that you can quickly show, Uday.
Absolutely. So we've introduced high-speed cut patterns. We call it high-speed cut pattern in our AlibreCAM product, and this is available both in 2-axis pocketing and as well as 3-axis roughing operations in here. So if you take a look at the 2-axis pocketing operation under your cut parameters tab, you will find in the cut pattern you have an option to pick high speed. You can select the high-speed cut pattern in here, and as you generate the toolpath, this actually creates a high-speed cut pattern. As you take a look at the toolpath preview here, you can see it starts out with a spiral cut pattern and creates a constant tangential arc. So it basically helps you prolong your tool life and also, makes it a lot more efficient. Now, this is also available in slot machining. If you're programming a slot, it automatically does a high-speed cut pattern as well.
Yeah, you might have heard the term trochoidal machining. That's when we are machining slots using the high-speed cut pattern, that's in effect what you're getting. Basically, we're following a trochoid when we're machining that. So thank you, Uday.
Thank you, Joe. So this can also be found under our 3-axis method. So I can select 3-axis and roughing. If you go over to your tool definition, I can pick a tool for it. I can go into the cut parameters, specify the cut pattern as high speed, and generate. That will create you a high-speed cut pattern in here. And there's the toolpath. So this is offered in 2-axis pocketing, 3-axis roughing, and also slot machining, and it's available to you in standard configuration and above. So if you have standard, expert, pro, or premium, you will have access to the high-speed cut pattern.
Okay, I have another question from a user asking, do we have engraving toolpaths?
Absolutely, we do. Engraving is offered in all our configurations of AlibreCAM, and you can find this under the 2-axis methods. You have 2-axis and engraving. So engraving can be used to follow or program 2D or 3D closed and open curves. And you could be using any type of tools. One of the enhancements we've added in 2018 is you can use pretty much any type of tool for engraving. So let's say you wanted to follow like a helical pattern. You can use a thread milling tool and use an engraving toolpath for it. So engraving can be programmed with any of these tool types, and it is available in all our configuration of AlibreCAM.
So the engraving toolpath is basically what we're doing in the engraving toolpath is driving the tool along that the center line of the tool along the curve, which is different from pocketing or profiling. We're actually offsetting the curve by the tool radius. So that's the difference between engraving and the other toolpath methods. So while you're up there, Uday, there's another question. What are those little windows that pop up when you're moving your cursor? So can you explain that tooltips?
Yes. As a part of our enhancement to our online help system to help the users out to get to know better about what each of these options or parameters are, we've introduced what is called context-sensitive tooltips in AlibreCAM. So as you hover over any of these options in the machining operation dialog, you'll see that a tooltip pops up for, after a fraction of a second to enable the user to help you identify what these parameters are or what would happen when you select this. So for example, if you go into the cut parameters and if you hover your cursor on the cut direction here, it tells you what is the difference between a natural versus a reverse, and each of these have a tooltip in here, so you can basically learn about it without having to go into the help system. You don't have to click on the help icon to launch the online help. You can interactively get help from the system, so to make your programming workflow a lot more efficient in here, so to help you get to know better about each and every option that's available to you in AlibreCAM.
A couple of notes on that. We also have, a lot of these have also graphics incorporated, so yeah, it's very helpful. And the other thing is, once you get more familiar with the system, you can also turn it off. If it gets a little bit, repetitive, or you already know how to use the system very well, you can actually go to the options and turn the tooltips off. So it's a pretty handy device to have.
And you can find those options under Preferences and User Interface, and you could turn off the Show Context tooltips right in here. So I just programmed an engraving toolpath in here, and I picked a face edge from this 3D model. I'm using a engraving tool for it. So as I'm running a verification here, so you can see that it's following along the 3D curve. So I apologize, I chose a flat mill. I was supposed to put an engraving tool in here. There it is. So you can use engraving for both 2D and 3D geometries, and it can be found under the 2-axis methods.
Folks, if you have any questions, go ahead and put put them on the chat window. And Uday, we can't hear you. I don't know if you muted yourself. So
Yeah, I just did. I was just waiting to see if you had any additional questions.
there's another question, Uday. Can you engrave in 4-axis? Yes, we can do that as well. Very similar to the engraving in 2-axis. And again, you select a curve and you select the 4-axis method. Uday, can you show that very quickly? We have a few more questions coming in. We're doing okay on time, I suppose. So
Absolutely. So in 4-axis, you can find the engraving method right over here, 4-axis and engraving. And you can actually select either a sketch or you could pick a face edge. So in this case, I'm just going to go ahead and pick this face edge right in here. Specify a tool for it. And then you can specify also multiple passes if you need it and generate your engraving pass. So engraving is available in 4-axis starting with the expert configuration of AlibreCAM. And if you have the 5-axis module, you can also do curve projection to use it like an engraving operation. So it'll follow along the surface and the tool will be normal to the surface following the path of the curve. So there's a method in 5-axis called curve projection, which can also be used like an engraving path for programming in 5-axis. And if you wanted to lock this to a 4-axis, you can do that by selecting 4-axis. So the curve or the sketch that you select will follow the surface and it'll be normal to the surface and locking it to a 4-axis.
there's another question here, Uday. Can you create tabs in 2-axis? Tabs or bridges? Yes, we definitely can. So if you can show that.
Sure, certainly. So earlier I talked about how we can insert bridge points. So there's 2 ways you can introduce tabs. One is you can do automatic bridging and tabs where you actually let the system automatically create the tabs uniformly. That's one of the ways to do it. Or if you create a predefined region and you go down to the advanced cut parameters, you could specify bridges and tabs, and these could be triangular or it could be rectangular. And if you had the predefined region created and specified the bridge point locations, you will see that the tabs would be created in exactly the locations where you specified those bridge points in here. So I'm regenerating the toolpaths, and you notice that the tabs are applied. So in this case, I have a rectangular tab created, and they're created exactly where you have the bridge points defined. So you can specify the height as well as the length for these tabs. Now, one of the enhancements we've introduced in version 2018 is the ability to also reduce the feed rate on descending motions when you have bridges and tabs. So when you select this and you specify a reduction factor in here, it'll use the plunge between levels feed rate reduction factor, and on every descending motion you can also reduce the feed rate with bridges and tabs. So this is a rectangular tab we've introduced, or bridges and tabs. Or if you want to switch this to a triangular, you can just go back to the advanced cut parameters and pick triangular for bridges and tabs. So there's 2 different ways how you can define tabs. You can also precisely place the location where you want these tabs to be along the model. And this is available in 2-axis profiling, and it's available in all our configurations of AlibreCAM, bridges and tabs.
I think there we have one more question to take. That would be, there's a request for you to show a little bit more of the machine tool simulation. So if you can do that, that'll be great. Thank you.
Sure, thank you. So let me go ahead and pull in one of the other examples in here. So as you go into the machine tool setup, you would first have to define this as load from file, and then you pick your current machine tool from the list. So we have a wide range of machine tools that are included. You can select them from the list. Now for this particular example, I'm just going to pick a generic CNC mill, and then when you pick OK, it actually you can, before you select it, it actually displays a preview of the machine tool. So this is a 3-axis standard mill, like a knee mill. And then once you have your machine tool defined, you would want to go into your Simulate tab and make sure you select the machine tool visibility to be on. And as you select the simulation window, the stock simulation window, and you select your machining operation and then pick the play button, you will notice that the simulation now shows up with the machine tool in here. So you're seeing that the X and Y linear axis, the table in motion right here, and also the Z axis. Since we're doing a 2.5 axis, the Z is remaining constant as it goes from one cut level down to the next level. You'll also see the Z axis dropping as well. So the machine tool simulation comes included with our starting with our expert configuration of AlibreCAM. So you can program 3, 4, and 5 axis depending on the configuration of AlibreCAM that you have. So with the expert, you can simulate both 3 and 4 axis machine tool simulation. I hope that answers your question.
There's one more question, Uday. I think that would be the last question. We're kind of running out of time a little bit here, but how can you use avoid regions? What are the rules associated with it?
Okay, that's a great question. So avoid regions can be used in 2-axis or 2.5-axis operation types. So let me go over to one of these examples in here. So consider that I would like to face this part before I start programming my operations like pocketing or roughing operations in here. So avoid regions must intersect with the actual drive geometry, and avoid regions can be defined in 2-axis operations like facing, pocketing, profiling, and you'll see under the control geometry, in addition to the part regions tab, you have a tab for avoid regions in here. So I'm going to quickly create an avoid region in here. So let me go over to the sketching, part modeling, and activate a sketch. I will go ahead and
So for those of you who are not familiar with the avoid regions, we have introduced avoid regions in a couple of releases back to allow you to model clamps and fixtures that you really want to avoid when you're machining. So that's the motivation behind using avoid regions.
So I've defined 2 areas for avoid regions in here. I'm going to select 2-axis and facing. And now I'll select my drive regions. For that, I'm just going to go ahead and pick those face edges from the top of the part. I'll accept those. And now I go into the avoid regions tab, and I'm going to select the sketch I introduced as my avoid region. I specify a tool for it, specify all your cutting parameters, and then generate. So now you can see that clearly it avoids those regions that you picked in here. So let's go ahead and take a look at the simulation. And I'm going to go back and change my stock in here. So we'll add a little bit of thickness to the stock and run a verification. So you can see it clearly avoids those areas that you define for avoid regions. So you can have one or more avoid regions. Your avoid regions need to intersect with the part region, and you can define them under the control geometry tab. Hope that answers your question.
I think it does today. I think we're reaching the end of the webinar. We have a few other questions, but what we'll do is we will respond by email to these questions. So thank you everybody for a really good webinar and all of your participation and all these questions that you've asked. As mentioned before, we will be sending out the recording of the webinar in a couple of days. We'll clean it up and send you a YouTube link. And you can reach us at sales@mexsoft.com by email or those phone numbers up on that screen. We're also available for chatting if you go to our window. If you have any sales or support related questions, send them to the Skype address. If you have support related questions, just send them to support@mexsoft.com. So again, thank you very much, and hoping to see you again in a webinar in a month or so.